Hello, ladies and gentlemen. Today we are going to be working on section 8.4, working on special parallelograms. We have already talked about parallelograms and their properties, and we've also talked about the number of ways that we can prove a quadrilateral is a parallelogram with given information. So with these parallelograms that we have here, these special ones, rhombus, rectangle, and square, keep in mind that they will have all the exact same properties of every other parallelogram. They just have a few specific features, and so they're just more specific types of parallelograms. So here again, this is just a review. Remember, these are all the ways that you could show that a quadrilateral is a parallelogram. Hopefully you were able to understand this and perform well on the quiz that you did. So moving forward here, a rhombus is a parallelogram with four congruent sides. So again, whenever we say rhombus, it's already understood that it is a parallelogram. So what does that mean? It means that it has both pairs of opposite sides that are parallel. It has opposite sides congruent. It just so happens that all the sides are the same. So you still have these opposite sides are congruent right here. But it's just they happen to all be the same measure. Remember also that when you say parallelogram, the opposite angles are congruent. And you also get from parallelogram that the diagonals bisect each other. So the rhombus has all of those same properties as a parallelogram, plus it has four congruent sides. That's by definition. And we will see that there's a few other special properties with a rhombus as well. So this would be a good time, again, put these things in your notes. You can follow along with the blank lesson as we go through. Rectangle is a parallelogram with four right angles. So again, all the properties of parallelograms will apply to this rectangle. This is just a special parallelogram. So we have both pairs of opposite sides are parallel. We have both pairs of opposite sides are congruent. We have opposite angles congruent. And we have consecutive, I didn't talk about that on rhombus, but you also have the consecutive interior angles here are going to be supplementary. And of course, the diagonals will also bisect each other. So a rectangle is a parallelogram with four right angles. Now, here are some of the additional properties that we have for rhombus. So a parallelogram is a rhombus if and only if the diagonals are perpendicular. Remember, they're still going to bisect each other because that's a property of parallelograms, but they also end up being perpendicular. So all four of these angles in here will be 90 degrees. Remember, when you're talking about if and only if statements, biconditional, okay, we can have a parallelogram being a rhombus, and then these two properties, okay, will apply. Or we could show that these diagonals are bisecting the opposite angles, or the diagonals are perpendicular, and that will then tell us that it is in fact a rhombus. So I talked first about the diagonals being perpendicular, but the other property here is that the diagonals bisect the opposite angles. So these diagonals right here are going to be bisecting that angle. So the diagonals are bisecting those angles, meaning each side is the same. The other property for rectangle here is a parallelogram is a rectangle if and only if the diagonals are congruent. So these diagonals right here are not only bisecting each other, but they're also the exact same. So they're the same length. So again, these are biconditionals, so if and only if. If I can show a quadrilateral has diagonals that are congruent, then I know that it is a rectangle. Moving forward, okay, we have one last one, and that is a square. And a square happens to be kind of a hybrid between a rhombus and a rectangle. What that means is it is both, okay? So it's both a rhombus and a rectangle. So what that means is that all four sides are congruent and all four angles are right angles, 90 degrees. So all of those properties of rhombus and rectangle will now apply to a square. So if we go back again, we know that not only are the diagonals bisecting each other, but they're also going to be congruent. We also know that they are going to be 90 degrees because that is one of the properties of a rhombus. So all four of these angles in here will be 90 degrees. And we also know that it's bisecting the opposite angles. So those two angles are going to be the same. And since it's a 90-degree angle, we now know that those angles will be 45 degrees. And again, a square is a parallelogram. So all the properties of parallelograms that we already talked about still apply. So we have these consecutive interior angles right here. Have to be supplementary. And the opposite angles have to be congruent, which they are. The opposite sides have to be congruent, and in this case they're all four congruent, and both pairs of opposite sides have to be parallel. So you just have to keep going back to all of those parallelogram properties and remembering that the parallelogram properties apply to square, rhombus, and rectangle. So here's kind of a Venn diagram that kind of shows the overlap. So you have the four properties of parallelogram that apply. So they have four properties that apply to every parallelogram. And then all four of those properties are going to apply to all of these. And then each additional special parallelogram has its own special properties that do not apply to all parallelograms. So, a couple quick examples. For any rhombus, A, B, C, D, decide whether the statement is always or sometimes true. Well, they told us it is a rhombus here. That's already by definition. So what we want to know is angle B right here going to be congruent to D. Is that always going to be the case or sometimes? And in this case, it's always, because it's a parallelogram. Okay, so what about the next statement that says, is AC going to be congruent to BD? So AC right here, is that going to be congruent to BD? Well, it is sometimes true, and it's only going to be true if this rhombus is a square. And remember, we're never going to just look at the picture to decide, okay? We're going to look at what given information we have. All right, moving forward to another example here. So for any rectangle, again, we're told it's a rectangle, so we know that it's a parallelogram. Decide whether the statement is always or sometimes true. So now we want to know, is WX going to be congruent to YZ? And that will always be true, because again, it's a parallelogram. And that's one of the four properties of parallelograms. So now we'll look at the next one. Is WY, so WY right here, this diagonal right here, well, that's not a really great color. Let's try something else. Is WY, oh, then it didn't give me my color. Is WY going to be perpendicular to XZ? So what we want to know is if this is going to be a right angle. And again, that is not necessarily true in all rectangles, so that's going to be only if it's a square again. So, just got to keep working on this stuff. Now, when we ask you a question like this, you can only use the given information. So when it says, what type of figure is this? We have to look at what we have. Well, first of all, what I like to do is I like to double check and see, first of all, is it a parallelogram? Well, I can see that even just the fact that opposite angles right here are congruent, so it is a parallelogram. So then if it's a parallelogram, am I given any information about, is it a special parallelogram? Well, I have 4 right angles, so that means it's a rectangle because of these 4 right angles right here. Oops. Okay, so now that I've shown that it's a rectangle, now I need to decide, well, is it also a square? And because I have this marked right here, that's perpendicular, that's the feature of rhombus, and since it's both a rectangle and a rhombus features, then we can say the most specific name for this would be a square. So these are the kinds of things that you should ask yourself as you are working through problems, making sure you're checking for all of the different properties that are given, not necessarily, again, what the picture looks like. And one last example we have here is kind of interesting. It says, will this window frame fit a rectangular window? And when you look at the window, you're like, hey, sure. I mean, you can see the dimensions and it looks like it's a rectangle. And you can see that this 44 and this 44 are the same. So this 33 and this 33 are the same. So we know that it's a parallelogram for sure because we have both pairs of opposite sides congruent. But is it a rectangle? Well, we don't know anything about the right angle in here, so we can't really determine the angle. So we could measure the angle, okay? And if we have right angles, then it will be a rectangle, or we could measure the diagonals because the diagonals have to be congruent. And they actually use this a lot with construction because right now, this angle right here, might not be 90 degrees. They try to make it 90, but that's one way they check to make sure that it's 90. I mean, they assemble it as a 90-degree angle, but the way they check to see for sure is they actually measure these diagonals. And in this particular problem, the carpenter measures the diagonals and they are not the same. And so it is not a rectangular window. So if he goes to and orders a rectangular window that size, it will not fit in that opening. He needs to go back and fix his angles there. So that's just some basic information. You might want to read through the textbook examples and so forth for some more information. Today, I'm going to have you do something a little different with the homework. I'm going to actually have you, pull up the textbook and either download that into Notability or just do it on paper and then submit the paper as well. So these are the learning targets for today, and these are the homework problems for you to work on. Please take advantage of my office hours. Email me or message me on Schoology with any questions you have.